Hello everyone, and thanks for joining me today for this free Go Bootcamp. I'm Corey Lanou. We're going to cover several areas of Go, just very briefly to give you an idea of the power of the language and why it exists. So before we start, let's go through some basic resources. First of all, where can I find this slide deck? So you can share this link with any of your friends, and basically you can go to gopherguides.com/redeem/free-go-bootcamp. That will get you this slide deck along with the actual video recording as well. One of the things I always tell everyone, especially if you're new to Go, is you really should get on Gopher Slack. It's an amazing platform that allows you to communicate and share ideas with many other Go developers. There's currently almost 30,000 registered users on the Gopher Slack. It's free to join, and it's definitely very useful. So if you're not on Gopher Slack yet, I think it makes a lot of sense to get out there, and there's a lot of great people, and it's very, very friendly, even to new people. Additionally, if you aren't part of your local Go meetup, I definitely recommend joining them. Google just made a big push to get all of the meetups joined to the Pro Go meetup. So the meetups are becoming more prevalent. It's a great way to meet people in your local area and share your ideas and projects as well. I used to run several of these meetups. It's a fantastic way to meet people and really get up to speed on Go. So if you're not part of your local meetup, definitely get part of that. Finally, the Go Playground is a place that we use to share a lot of code snippets. Many of the code examples in this presentation can be run on the Go Playground as well. So if we take a look at that real quick, you'll just see basically you can create code out here and you can run it. So this allows you to basically create and share snippets. Now what's really neat about this, if I change this and say hello Gophers, and I run this, you can see it changes the code. Additionally, what's most important is you can hit the share button here, and then you can copy this link. And if I copy this link and open another window with it, you'll see that it's the exact code that I just shared. So this allows you to basically share, different thoughts. If you're having a bug or you need a different idea on how to do something, it's a great way to actually share code snippets in the community. So I highly recommend using that. Lastly, if you want to see the video that we're actually watching right now, you can go to Gopher Guides TV and check out the free video section there. And that is where this recording will actually be posted. We also have several setup guides here, so if you haven't had a chance to set up Go on your computer, don't worry about that. We're not going to require that today for this bootcamp, but there's a detailed guide here as well as here. So if you need to actually set up Windows or Linux or Mac, go ahead and check out these guides. They're really good, they're very detailed, and they'll get you set up. All right, let's go ahead and talk about why Go. So have you ever wondered what companies are using Go, why Go was created, what problems does Go solve for? This chapter is going to walk through many of those aspects. If we think about companies that are using Go, they're companies like Google and Facebook and Yahoo, companies like Netflix and Uber, and the list goes on. So there's actually a list at the bottom here of the Go wiki that actually shows a list of companies that are sharing that they do Go. Go probably touches you every day in your daily life without realizing it. If you've ever downloaded something from the App Store on Android, you've probably used Go. If you've ever taken an Uber, you've used Go. If you've ever watched a video on YouTube, you've used Go. This is how prevalent Go is at this point. It's being used at virtually every aspect of all major companies. So if you're working in a major company, chances are pretty good that somebody in your company is using Go and you don't even know it. So why Go? Why did we need this new language? Really, because we need a new mascot, right? Okay, let's face it, the Gopher is really, really cool. But seriously, if we really think about why Go, Go was created to make software engineering easier. And software needs to scale beyond machine scale, but at human scale as well. And so what does that mean when we talk about human scale and not machine scale? Well, let's take an example of Google, right? So Google has roughly 20,000 engineers or more. It's a very, very big team. And let's just do some basic math. So let's say they're working on a project that you have to compile every day. And let's say that compile takes 65 minutes a day, okay? In Go, that same project may take 5 minutes. Go compiles very, very fast. And there's many projects, I'm sure you've probably worked on some, that take a long time to compile. Now, obviously, when you're compiling, you can do other things, but let's face it, as developers, most of us, we aren't that productive when we're compiling, right? We might get up, go take a break, get some coffee, those types of things, talk to a friend, check our email. We're not being super productive. So it's kind of a waste of time, right? Now, if we compile only once a day, and we work on the code 40 weeks out of the year, that's 40 hours per year per employee spent compiling. Let's say we're paying an average of $100 per developer, which isn't crazy. That's $40,000 a year that you're actually paying that employee to compile. Now, if we have 20,000 employees, that gets to be a pretty big number, right? That's 800,000 or 800 million annually cost savings for when you have 20,000 engineers. So when we talk about scaling, this is what we talk about scaling at human scale. This isn't just at machine scale, it's human scale as well. So in the words of Andrew Duran, and he's one of the people that worked on Go early on, software should be simple and software can be simple. And what does he mean by simple? He means it's small, readable, consistent, orthogonal, predictable, robust, and useful by default. Now, everybody always asks me, what does orthogonal mean? And orthogonal just means isolated or partitioned, right? So these are the tenets for creating simple software with Go. Now, many of these slides are actually taken out of Andrew Duran's Railsbury's presentation. So if you want to see more about this, go ahead and check out that presentation as well. We're going to go ahead and hop into Go at a glance though real quick and kind of talk about some of the features here. So the language features, it's compiled, it's statically typed, has a really clean syntax, is a really simple type system, concurrency primitives, right? So concurrency is built into this language from the ground up. It's a very rich standard library. It's open source. It has an amazing set of tools that ship with it. And testing and benchmarking were part of the language specification, right? They were not an add-on later. It was actually designed into the language. So that actually makes a really big difference. If we look at the Go command itself, the Go command is the primary tool for working with Go project. It runs tests, benchmarks, formats your code, and does a bunch of different things. So this is kind of your toolbox right here that you get automatically when you get the Go tool command. If we look at our very first program here, it's very simple. So this is our basically hello world, right? We have a package main, which is just going to be the main program here. We're going to import the fumped package. And I know many people might think that's the format package, but in Go, we call it the fumped package. We have a single function called main. Now, this is how Go knows that this is the entry point to your program. So if it sees a package called main and a function called main, this is your entry point. And then we're going to use the fump.println to go ahead and print hello Go. Now down here, you'll see there's a little button that I can actually click the play on. This actually jumps out to the playground. And from here, I can simply click run and see this works, right? So that's our basic hello world program. So bang, we go ahead and we have our brand new first Go program. So the NetHTTP package actually provides an HTTP server as well. So if we look at this, this is basically us. We're going to launch an HTTP service. A little bit more involved, but fundamentally, it's just going to do some simple things. We're going to go ahead and have this handle func right here. And all this handle func does is basically wire up and print out hello web. That's all we're doing. And so this is basically like a handler like you'd think about Rails or something like that. And then I'm going to go ahead and do some housekeeping. I'm going to go ahead and print out that I'm starting the server. I'm going to listen and serve on the localhost 8080. And then I'm basically going to go ahead and see if error doesn't equal nil, I'm going to log.fatal. So this is me basically spinning up a very simple web service. So if I go ahead and I run this locally, we can see this actually works. So let's go ahead and spin that up real quick. Okay, I've got the server running. So let's go ahead and actually see that it's really running here. And I said I was spun that up on localhost 8080. So if I copy that right there and I run that, there it is, hello web, right? We proved that that's actually working. Now, this is a high-performance denial service hardened production-ready web server. It actually serves dl.google.com. So people ask me all the time, you know, can I use the native web service that comes with Go, or should I use a third party? The web server that comes with Go is fantastic. It is definitely production-ready. This is something you can use in high-demand, high-scale scenarios for sure. Okay, so now, we already talked about this before, but basically we have our first Go program that we created. And we basically, if we want to create this from scratch, we can just create a file called hello.go with any preferred text editor. And again, we've got the package main, we import the fumpt command, and then we have the func main, fump.println hello go. It's that simple. Now, if we want to run this, it's as simple as saying go run hello go. So if I go ahead and copy this right here. Okay, so here's our hello go program. If I want to go ahead and run that, I say go run hello go. And there it is, runs the program. Now, when we think about what happened here, this is actually very interesting. From the time that I said go run hello go, it actually looked at the source code, compiled it to a binary, and ran the binary and showed me the output. Now, look at how fast that is, right? If I go ahead and put a time in front of here, it does that very, very quickly. Now, if you think about other languages, and I'm not going to start a language war here, but there's certainly languages that just to spin up the runtime takes longer than that. In Go, we can actually compile and run the program in sub-second. It's that fast. So again, very, very fast compile times in Go. All right, so now we wrote some of our first Go programs. So let's go ahead and keep on trucking, and let's go into something a little bit more in depth. So let's talk about command line programming. So Basic command line CLI, Go allows you to quickly and easily create command line programs. What's really nice about this, because you can cross-compile, is many software CLIs now are written in Go because they can write once and deploy anywhere. So you can write a CLI, works in Windows, works on Linux, works on Mac, and that's very powerful that you don't have to go ahead and keep supporting different code bases for those different architectures and platforms. So that's one of the main reasons that CLI for Go is really dominant out there, and it's really popular. So in this example, we're going to cover the basics, and the first thing we want to do is talk about the flags package. Now the flags package basically is how we handle arguments in Go. So if you want to learn more about the flags package, you can click on this link and learn more about it. We're just going to cover some really basic pieces here to start with. So in our first program, we're going to create a CLI.go file, and we're going to see out of the box how we get some of this stuff going. So if I create a CLI.go, I'm going to basically create the program. It's package main again. Now this time you're going to see I'm going to import the flag package as well as the funct package. Now I'm going to have my function main. I'm going to create a variable called cmd for string, and then I'm going to use this flag.stringvar. And what I'm doing is I'm basically giving it a pointer to that variable, and then I'm giving it some basic syntax. So I want it to be the cmd flag, and then I want the default, which is going to be blank for now. And then I'm going to tell it, here's my help text. My help text is cmd can either be hello or bye. Then I have to call flag.parse. Now what that does, it goes ahead and parses all the arguments and stuffs them into any variables that I just went ahead and wired up via things like stringvar. So at this point, when I call flag.parse, it's going to store the contents of that argument cmd into the command variable that I created here earlier. At that point, I have a simple switch. If I passed in hello, I'll print hello. If I passed in bye, I'll print bye. Otherwise, I'm going to print out the flag.usage, okay? So that's actually pretty cool. It'll actually give me my usage, so I don't have to build that by default. So now if I want to run that, just like the other program, I say go run CLI. So there's my program on the left, the one that we just looked at. I'm going to go ahead and run that now. And if I run it with no arguments, you see I'm going to get this, right? It's going to go ahead and print out cmd string, and it gives me my usage at this point. It says cmd can either be hello or it can be bye. Now, the reason we get this really strange method up on top where it says usage of /var/folder/ all this gobbledygook is due to the fact that when I say go run, it actually has to build that binary and run it. And it builds it in a temporary directory. So that's why we're seeing that. So you don't have to really worry about that if you're using the go run command, but just understand that's why you see this temporary gobbledygook a little bit. So if we break it down a little bit further, we can see we didn't provide any arguments, and because we didn't provide any arguments, it just prints out the usage. So now let's go ahead and actually pass an actual argument to it. So let's go do this now, and I'm going to pass hello, and as you can see, now it prints hello back. And if I print bye, if I pass in bye, it prints bye. So that's how we know the program's actually working, and that's how we're passing in actual commands and using the flags package to wire them up. So the stringvar method just allows us to tell the flag package to look for specific argument names. In this case, it was command, right? So if we want to know more about that, I have a link to the documentation here. You can check that out. Again, pretty straightforward. We give it the actual stringvar that we're pointing to. In this case, it was command. We give it the name of it, which was cmd, and then the value. Many times I just give it the actual value of the variable I have, which is typically blank, or maybe I have it set to a default already. And that makes it really easy to do that, set up then at that point. Now, what if we want to actually compile the binary? We can actually do that pretty easy as well. So if I want to build it, I can say go build CLI. And now you'll see I actually have a executable there. So now if I run that, I can just do this, and it runs it, right? Now it gives me the usage. Now notice this time I'm not getting that big var temporary file, all that kind of stuff there, because it's the actual binary. And I can prove that I'm running this. Now I can go ahead and pass in cmd, and there it works. So now I have an actual compiled binary. So that was pretty quick, pretty easy to use. And lastly, we can cross-compile a binary and go very quickly. We can use two environment variables, or we can set them on the fly with the actual command. They're called Goose and Gorch. So Goose is the actual operating system we're going to target, and Gorch is the architecture we want to support. So let's say I want to build something from Windows, and I'm going to do this from my Mac. I can actually do this right here on my Mac. I can actually build this. Now, if I look at my directory here, now you'll see I have a CLI.exe. I can take this binary file, throw it on a thumb drive, hand it to somebody with a Windows computer, and then they can go ahead and run that. Now, their virus scanner might go nuts, but fundamentally, this allows me to cross-compile to Windows very quickly or any other platform. So you can do this for Linux distributions, all that kind of stuff. So very, very quick and very easy to do. So that's basically the CLI. So let's go ahead and jump to the next chapter. Let's talk a little bit about concurrency. So one of the big draws of Go is concurrency. It really does a great job at it. It's a primitive. It's built in from the beginning of the language spec. It allows you to do really complex things with really simple logic. Now, if you've done concurrent programming in other languages, I think you'll find that it can be a little bit tedious and hard to understand. And Go has some really simple concepts that makes things really easy to code, very difficult tasks very easily. And you can actually follow the code logic pretty quickly too. So in this example, we're going to cover the working basics of concurrency. There is a really fantastic talk I highly recommend. It's Concurrency is Not Parallelism. It's on YouTube. It's by Rob Pike, one of the creators of the language. He does a fantastic job at explaining this. So definitely one of these things I recommend to go out there and check out his presentation. It was the very first thing I watched when I heard about Go, and it was immediately hooked. Like, it was that powerful for me. So hopefully you'll have the same experience. But when we talk about concurrency, concurrency is about dealing with a lot of things at once, versus parallelism is about doing a lot of things at once. Now, this is always a hard concept for people to understand, so I kind of explain it like this. If I want to go ahead and I want to dig a hole in the ground, and I have a shovel, and I can go ahead and start digging a hole, right? And now let's say I want to dig 2 holes. I can't dig 2 holes at the same time. I'm one person, I'm one resource, right? But I can dig them concurrently, meaning I can take one shovelful out of one hole, walk to the other hole, take another shovelful out, walk to the other hole, take another shovelful out, right? I can do that. So I'm doing these things concurrently. I'm actually addressing more than one task, but I'm sharing my time, right? I'm slicing my time. Versus if I want to do it in parallel, I have to have another resource. I have to have my buddy come help me. I have to have someone come out with another shovel and actually start digging that hole next to me. So that's the big difference about concurrency and parallelism. Now, you can do concurrent things in parallel. So that's still something you can do, but concurrency is not by nature parallelism. So let's talk about the tasks that we're going to solve today. So let's say that we've got a set of operations that are going to take an unknown length of time. We want to do this as fast and efficiently as possible. And so we're going to use Go's built-in concurrency. And the example we're going to do today is, let's say we have a list of websites that we want to monitor, and we want to monitor the response times, right? So we're going to have a file that goes out and basically retrieves all the websites and measures the response times for them. So let's write a real basic CLI to start with that actually doesn't do anything other than just accept some arguments. So we saw the flags.stringvar earlier. There's also flags.args. Now what flags.args does, basically it just gives us all of the arguments that were non-flags, okay? So sometimes you're going to pass in things like file names, things like that are non-flags, and you can get that with the flags.args. So let's go ahead and run this real quick, and we'll see what that looks like. Okay, so here's our very simple program that just has flags.args. And if I run this right now with nothing, it just prints out an empty slice. That's all I'm going to get. But if I run it with some actual arguments, like let's say Google and Yahoo, you'll see they actually come back like this. So now I have a slice, which is like an array in Go, but we have a slice of actual values now we can work with. So this makes it really easy to kind of start parsing our input. So from here now, we actually just want to retrieve some actual response times. So we're going to do a couple things. First of all, I want to know 2 things. I want to know how long does the entire program take to run, and then how long does it take to run each individual site. So for this, we're going to go ahead and set up the sites argument. So we're going to create a sites variable here. We're going to use the flags.args to actually capture that variable. I'm going to create a variable called start. I'm just going to give it time.now so I know what time we started at. I'm going to call process sites, which we're going to look at next, which actually retrieves the websites. And then I'm going to print out how long the actual process took. Now, this is the entire process. All right, so this is the process sites. So this is a very simple function. It takes a slice of string, which is our sites that we passed in earlier. I'm going to use a for loop to go ahead and range through the actual sites. I'm going to go ahead and create a begin variable to capture the current time, because I want to know how much time it takes to actually get each individual website. At this point, I'm going to retrieve the website. I can use the http.get function from the system library. It's a very simple function that's included with Go that allows me to grab any resource on a URL. I'm going to store the response and the error. Now, for any reason I error out meaning error is not nil, I'm just going to print out the error and then continue the loop. I'm not going to continue on. However, if it doesn't error out, which hopefully it doesn't, I can now print out what site I was actually looping through and how long it took to retrieve and what the status code was. And that's what I'm printing out at the end. So that's that one right there. So now let's go ahead and run this. Okay, so here's the program on the left. You can see the entire program now. You see the main and the actual process sites. It's all put together. So just what we covered. And if I go ahead and pass in these different arguments, now I'm going to try to retrieve Google and Yahoo, and it's going to go ahead and run. It's telling me it took the first site, Google, 225 milliseconds. It took Yahoo 1.15 seconds, and the entire process took 1.381 seconds, right? So basically it took as long as all of the sites I'm asking for put together, all of them summed up. So let's see if we can speed things up a little bit by making it a concurrent program. So we can use a wait group to actually make this happen. And the thing that we need to do is we're going to use a couple of concepts here. We're going to use a go routine and a wait group. And what we're effectively doing is we're synchronizing our tasks. We want to make sure that when I do these different routines that they synchronize, meaning they finish before another one, before the actual program exits. So that's really important. So when we think about concurrent programming, it's always about sharing memory and it's always about synchronizing the actual tasks in Go routines. That's really all it comes down to. So if we go ahead and look at the changes to this program, they're actually pretty simple. Fundamentally, all we're going to do in the main is we're going to add a sync.wait group. And this basically is just a counter, and a sync.wait group allows us to say, I'm going to do X amount of things, and when they're all done, then you can unblock and keep going. So if we look at the code here, I create the wait group. I've got the start, which I've kept from before. Now this time I'm going to do a waitgroup.add, and I'm going to give it the number of sites that we're going to process. So this is based on the number of arguments we sent in. So if we send in 2 arguments, which is Google and Yahoo, it'll actually add the number 2 to the wait group. This means it's going to expect 2 things to happen before it's done. Then we call wg.wait, which is waitgroup.wait. Now what this does, it blocks the program at this point and says, I will not continue until the wait group has been satisfied, meaning we've finished everything. So how do we satisfy everything, okay? Well, let's look at the process sites. What do we need to change here? The only thing we're doing here now is we're passing in this wait group. The for loop stays the same. And now you're going to see I'm going to use an anonymous function with the keyword go in front of it. And what this is going to allow us to do is basically it's going to allow us to create a bunch of Go routines that execute in their own space and across different system threads. This will allow things to actually run concurrently. So if I look at this function, it's going to take an index and the site, and then I use this keyword defer waitgroup.done. Now waitgroup.done basically says I'm going to decrement, meaning I've got a task done. So if we think about this, we're going to loop through the sites, right? We're going to create 2 Go routines, one for Google and one for Yahoo, and they're each going to call waitgroup.done. So they're both going to decrement, and we're going to have waitgroup.done decrement 2 times. This means we did the waitgroup.add and we added 2. We'll now see it decrement twice. When it decrements back down to 0, that's when that waitgroup.wait from the previous code actually stops blocking and allows it to continue. That's what we want because we know that both of these actual Go routines have finished at that point. Now, what does the defer keyword does? It basically says when this function exits scope, run this command. What this allows us to do is very easily say, when I exit for any reason, I want you to actually run our waitgroup.done. Now, if we look at this function here, we'll see there's actually 2 branches that can exit from this actual function. It can happen when we actually get an error or when we finish successfully. And because we use the defer, I don't have to worry about which branch that exits this function. I know that waitgroup.done will run regardless of which branch I exit the function from. All right, so that's the waitgroup.done. Then we have the begin variable that we create, capture the time.now. And the retrieving of the website is the same as before. We get the website. If it's an error, we print it out. Otherwise, we go ahead and print out the actual status again. The site took X amount of time to retrieve with the code of X. So that's how we do that. And then you'll notice that we actually do pass in these variables, and that's scoping them to this Go routine. This is very important because we want to make sure we put the current value of that index on the stack with the Go routine and not a pointer to it from the scope. If we do that, we could have really funny problems. We're not going to go into that here, but just understand that when you launch an anonymous Go routine, you always want to scope your variables. It's very important. All right, so let's go ahead and run this and see what happens. Okay, so here's our program again. As you can see on the left-hand side, we've added the wait group, and we've started to process with Go routines. And so if I run this now, we'll see that Google took 229 milliseconds, Yahoo took 983 milliseconds, but the entire process took just slightly longer than the longest program to actually retrieve. So this is actually really cool now. So we've actually dropped our time by, looks like 229 milliseconds, right? Because effectively at this point, they were both running. Now, how did it do this? How did it actually run this? Let's say that we even had one single system thread. How did it do this? So the way concurrency works in Go on a very rudimentary level is it basically looks anytime a Go routine is blocked or waiting, right? So in this case, as soon as I made a request to the http.get, that was an IO request, and it was waiting for a response from an external source. And the system scheduler knows at that point that the Go routine is in a wait state, and it says, oh, I'm waiting to get google.com. Let's go ahead and grab any other tasks, or in this case, Go routines that are waiting to run and schedule them to run while I'm waiting. So instead of sitting there and waiting for google.com to come back, it says, oh, I'm waiting anyway. Let's go ahead and run this other one. In this case, yahoo.com comes up and it starts retrieving. Yahoo.com immediately says, oh, okay, I'm now waiting for this site as well. And then it goes, oh, is this other Go routine ready? And it says, oh, it is. So google.com is ready to actually be processed. And it puts that Go routine back on the stack to be run again. So that's kind of how Go routines work at a very primitive level, is the system scheduler kind of time slices the system threads, figures out which Go routines are in a wait state, and then goes ahead and puts them either to work or to sleep so that it can run more than one. That's how concurrent programming works, very, very rudimentarily explained from this standpoint. So think if I had hundreds of sites to run, right? You can look at the sites.txt. I've got a link to it there. But effectively, you can look at the first 20 lines of the output from that, and you can see how much faster that's going to run. So now if I have 100 sites versus 2 sites, this is going to be a big difference in how fast I can get all these sites back, right? So if they all came back within less than 5 seconds, I can retrieve 100 sites in less than 5 seconds versus 500 seconds if I did them synchronously. So that's kind of the power that you can start to see now very quickly from concurrence. And as you can see, the code we had to change to go from a non-concurrent program to a concurrent program was just a few lines of code. It wasn't a lot of code at all. It was still very easy to understand what was happening, very easy to code and rationalize about. And that's kind of the power of concurrency in Go. That's the really cool part about it. So congratulations, if you did this on your own, you actually just wrote your very first concurrent program. That brings us to the net HTTP part of this. So we're going to cover the basics of creating your very first web server application. We're going to do the basic web server, some basic routing and templating, and using some external packages as well. So if we look at a very basic web server, we saw this kind of in one of our overviews earlier. We can create a very simple file called webserver.go and use some very simple things in here. In this case, we're just going to use a handler. Again, this is our basic handler. We're just going to print hello world, and then we're actually going to put in the actual URL. So I just want to print out the path that this is running from. Then I'm going to go ahead and run this and see the results. So let's go ahead and fire this up and see what happens. Okay, I fired up my actual web server. It's running on localhost 8080, and let's go ahead and verify that's running. So I had this open before. This was a different web service. So here we go. And now it says hello world from / right? So we see that there. Now what if I do /foo, right? We can see that. Now it says some foo, bar, etc., right? So this is proving that this is actually working as I expected it to. Now, the thing about this is we really don't want the web server to respond to any route we give it, right? So we can give it foo, bar, baz, whatever we want to give it, but that's really not ideal. We don't want that just to be open. So what we want to do is basically add some routing. So we can do that by using the actual Gorilla Mux router, and you'll actually see we can expand the code here. I haven't showed you that, but we can expand the code. We're going to actually include this right here, the Gorilla Mux router. So we can include that by just using the import. Collapse this back. And all we're going to do now is we're going to create a new router. We're going to use the strict /. If you want to know more about that, just look at the package that I've got linked above. And then we're going to go ahead and add the index. And what we're going to say is we're going to say on the / I want you to use the index function. Now, these basically take a handler at this point, and the handler is defined as a function that takes a response writer and a HTTP request. And so you can see down here I have an index function that takes a response writer and an HTTP request. This allows me to actually pass it into my router. Now again, the index does the exact same thing I did before. The only difference now is I've got it wired into a route. So we fire this up the same way, and we go ahead and test this now. Okay, so there my code is with the actual router in there now. Very simple code. And let's fire that back up. So now you can see that's running again. And if I go back out here, and I go back out to the index, There we go, right? That works now. Now what happens if I go to foo this time? Gives me a page not found. Now this is what I want, right? I only have one route defined, so I only wanted to actually respond to that one route. So this is actually what we want to work. All right, so as I alluded to before, we actually are using our first external package at this point. So even though we went ahead and we put that up in our import, right? If I look back here, we actually put that in our import. We still may not have that code locally to our computer. Now, if we want to go ahead and bring that code local to our computer, which is required for us to compile and run that, we have to use a go get command. So we can just simply say go get github.com/gorilla/mux, and that will place this code now on our local system for us to compile and run that code. So now we fire up the server again, and then like we just showed before, we can go to the 8080/, but if we go to foo, we get the not found page as we expect. So now, this is pretty basic, right? It doesn't look real pretty, but what if we want to use some actual HTML in here? Well, we can use the HTML template package for that. So in our index, nothing really changes for this. So to add the template, we don't really have to do anything here. The main's going to stay the same. But we do want a template. So in this case, I'm going to define a basic HTML template. I'm just going to use a constant. Now I can use backticks and go to create a multi-line text string. So this is really handy for anytime I want to use things like HTML or templating. And you can see I have a very simple HTML document. It's got a head, a title, a body, an H1, and with a title and then a body, right? Very, very simple HTML. So that's what I have there. Now, I have to be able to feed the data to this template somehow in Go. And so we typically do that by using a struct. So in this case, I can just create a struct called page data. It has a title and it has a body. Now you'll notice that if I look at the template, they've got these angle brackets and then dot title, and then angle brackets and dot body. These match up directly with the title and body fields of my page data. This way, when I go to render this actual template, it knows from looking at the actual data passed in or the structure passed in that these are going to line up. That's how it knows how to map the actual data passed in. So lastly, we actually need to render. Now rendering is a little bit more involved, and the easy thing to do here is just create a simple render function. I'm going to pass it an IO writer, and in this case, because I'm in an actual handler, I'm going to have the actual response writer available to me, so I can simply pass that in as an IO writer. This is kind of one of the idioms that you'll find in Go. We have IO readers, writer, idiom patterns all the time. It works out really nice. And then I'm going to pass in data, but I'm going to pass it as an interface, and I'm doing that because the execute takes a actual interface, so it can be anything. And this allows me to have a more versatile render at this point, so I can kind of send any data to that index that I want, and I can pass any IO writer. So at this point, I'm going to parse the template, and I just do template.new and give it a name. In this case, I'll give it index. And then I'm going to parse the HTML. Now, that HTML was that constant I defined earlier, right? That was the actual HTML constant, which is just a string of the actual template data for the HTML body. If I get an error, I'm going to return the error. Otherwise, I can call it a template.execute. I give it the writer, which in this case is going to write out to the actual web service. And then I give it the data, which in this case was the page data that I passed in. Now, if I get an error, return the error there. Otherwise, if it's successful, I just return no. So that's my actual render at this point. So now if I look at my index handler, so it stays pretty much the same, other than now I'm going to create this page data. So I'm just going to go ahead and create a local variable called PD. I'm going to set it to an instance of page data. I'm going to give it the title, which is going to say index page. I'm going to give it the body, which is going to say this is the body of the page. And then I'm going to call render, right? So here I've passed in W, which is the response writer from my actual index handler. And then I'm going to give it PD, which is the page data, right? So I handed it an IO writer, and I handed it an actual piece of data, which is sent in as an interface to the actual render function. If I got an error, meaning the error is not null, I want to write out a header saying I got a status internal server error, and then I want to write out the actual error as well. Otherwise, if nothing else happens, it'll actually get a 200 status OK, and I'll actually see the data that was actually rendered. So let's go ahead and run this and check it out. Okay, so here's the entire program all put together on the left side here. I've got my page data, I've got my constant HTML, I've got my main function, I've got my index function, and finally I've got my actual render, right? So that's all of my code right there. If I go ahead and run this, let's fire it up on localhost 8080, and let's see the results. And voila! Now I actually have a little bit better page. I have actually HTML in there at this point, and it's actually taking data from my actual handler. So that's your basic templating dance right there from the server side for Go. So if you want to learn more about doing web and web services in Go, there's actually a lot of resources out there. Buffalo is actually a great framework. So if you're not familiar with this takes a lot of the rough edges out of web development for Go. It has all the major features out there that you're really looking for. A lot of people kind of say this is kind of like the Rails of Go. So if you like doing Rails development, which is really fast development and really easy, Buffalo might be a really nice fit for you. It does things like migrations as well. It has just a ton of stuff out there. It does feel very much like Rails development, but you get the speed and security of developing in Go. So that's really, really cool. I actually wrote an article many, many years ago, which is about making a RESTful JSON API in Go. Now, while this is a somewhat outdated article, many of the pieces still apply here, so it's still a very practical article. If you've never written a RESTful JSON API ever in Go, this is really going to walk you through all of the building blocks. So definitely something very useful to read yet today. And finally, there's an actual Go book out there that is actually the Building Web Apps with Go. And you have to log in, of course, to see that. But if you want to see this Git book, it's a great book out there as well. Which now brings us into the finalize part. So I always like to end all of my workshops just basically letting people know things that they should be looking for or resources they can use out there to learn more about actual Go. There's some really good docs out there. So obviously the golang.org is the official Go site. There's a lot of tutorials and mini books on Go. Effective Go is the one thing I tell people, if you're an experienced developer, this is probably the first thing you want to read about Go. So if you're brand new to Go, this is definitely worth a read. This is something that I went to when I first learned Go. I didn't understand the entire document the first time through, and I found that if I came out here every 30 to 60 days and read this over from the top again, I would get a little bit further and understand a little bit more. So this was kind of something that I would read every 30 to 60 days until I got to the point where I could pretty much understand the entire document. And it really does give you a lot of in-depth stuff, but it talks to you as if you're an existing developer, and it really does jumpstart you. Godoc.org is a site that basically, if you're looking for a package for something, it's probably been written. Like, let's say I want to do image, manipulation, right? Here's all the packages for that. And what's really cool about this is it not only tells you here's the package that you might want to use for it, but how many open source packages are importing it. So it kind of gives you an idea of how popular is this package, how well maintained is it, how well adopted is that, and that's really important when you're looking at third-party packages. We talked about Slack earlier on. If you're not on Go for Slack, definitely get on Go for Slack. It's where you're going to get all your questions answered. Some great books and videos. There's a book, The Go Programming Language, I definitely recommend, and Programming Blueprints. If you're looking for other resources, we're a little bit biased, but we do feel that Go for Guides TV has a great set of self-paced learning videos out there. We have all kinds. We have free videos and subscription-based videos, so check that out. We do have our YouTube channel as well that we post free stuff to. O'Reilly has a ton of great videos out there. And Just for Funk is a great series by Francesc. I don't know if he's doing it anymore, but he's got a lot of great videos out there. Definitely learn something every time I watch any of those videos, so highly recommend that as well. Finally, we're Go for Guides. We do training and consulting. So we do online instructor-led workshops. We do in-person workshops. Any type of topic you can imagine. If it's Go, we probably have material for it. We'd love to come talk to your company and do some training for you. We do them all over the world. We do them for all kinds of companies, small, Fortune 500, it doesn't matter. And we love doing it. So we'd certainly love to help you out and make sure your project's going to be a success if you're getting into Go. We do Buffalo and Go consulting as well. And we also do Go and Buffalo support contracts and project audits. Maybe you're just launching your first Go project and you'd like somebody to come in for a day or two and actually kind of run through it and make sure you didn't do anything crazy, make sure it's kind of on par and going to be maintainable. So we do all that kind of stuff. So please let us know if we can help with any of those things. Finally, here's all of our instructors. So if you're interested in learning more about our instructors, we have all our information here, of our contact information. Feel free to contact us or reach out anytime if you need any help. Thanks for attending the workshop. I hope you learned something. If you have any questions, I'm always on Slack or Twitter. Feel free to reach out to me. I love talking to people in the community. If there's anything I can do to help, please let me know. Again, thanks for attending, and I hope you got something out of this presentation.
This video was brought to you by Go for Guides. If you are an organization, conference, or user group looking for Go training, please visit goforguides.com. For more great videos like this one, please visit goforguides.tv.